Okay, this lesson is lesson 2 of the second trig unit, and what we'll be doing in this lesson is solving second degree trig ratios. So in lesson 1 we solve first degree, second degree would be an x squared, that's a degree 2, but because we're doing trig ratios it's going to be sine squared theta, cos squared theta, and tan squared theta. How it starts is a review. So in class example number 1 they just want you to factor all of these questions, and even though we've never factored with sine, cosine, and tangent, it is going to apply the same way as the factoring rules that we learned in 10C and 20-1. What I'm going to do is I'm going to take tan of A and I'm going to replace that with a variable. So I'm going to say, okay, let y equal to the tan of A. So that would be 8y plus 4. If I said factor this, you'd say no problem. I'm going to factor by a GCF, and the GCF is 4. Divide that side by 4 and that side by 4. Your GCF goes in front of the bracket and your solution goes in the bracket. So 8 divided by 4 is 2y plus 1. Those are my two factors, 4 and 2y plus 1. But what I need to do now is go through and replace y with what I had originally took it out for, which was tan of A. So my answer would be 4, 2, tan of A plus 1. Close your bracket and you'd be done. This question here, sine squared theta minus 3 sine of theta. Again, if I was using y and letting y equal to the sine of x, what I would have is y squared minus 3y. And the GCF would be a y here. Y would go in front of the bracket, y minus 3. There's my two factors. At the end, I have to replace y with sine of x. So sine of x is one of my factors, and sine of x minus 3 is my second factor. You could do it this method that I've just outlined, or you could say, okay, I'm just going to up here divide that by sine of x, and this by a sine of x. Sine of x goes in front of your bracket, and your solution, sine squared theta divided by sine theta, is sine of theta, or sine of x, minus 3, because sine of x over sine of x would cancel. For C, let's let A equal sine of theta, or sine of x. So this would be 4a squared minus 1. If you were given this in 10C or 20-1, you should recognize it's a difference of squares. Two terms separated by a minus. Each term can be square rooted. This would be 2a minus 1 and 2a plus 1. That's my fully factored answer, and I need to replace a with sine of x. 2 sine of x minus 1, 2 sine of x plus 1. Remember, you guys, as we're going through this, the goal is that you're pausing, rewinding, writing all of this down. D. Let's change this to a squared minus 3a minus 28. This would be what we call factoring by inspection, or PSA 1. PSA 1 is just a different term. What we're looking for is a product, a sum, and an answer. The product is always that constant, or that C value times your A value. So I'm looking for what multiplies to negative 28 and sums to negative 3. So the two numbers that multiply to negative 28 and sum to 3 are negative 7 and 4. So my factors would be A minus 7, A plus 4. Remove your a at the end, and a is equal to cosecant of x minus 7 and cosecant of x plus 4. The last type of factoring, 2a squared plus 7a minus 4. This is what's called factoring by decomposition, or what I called as PSA 2. So product, sum, answer. Same thing, we're looking for that constant times the a value. So negative 4 times 2 is negative 8. I'm looking for a sum of 7. And the two numbers that multiply to negative 8 and sum to 7 are 8 and negative 1. PSA 2, you guys, it's called decomposition. So in PSA 2, we always have to decompose something, and you're always decomposing 100% of the time that middle term. always say to yourself, how do you get 7 A's based on this answer? Well, should be simple. 8 A's minus 1 A. 8A minus 1A is 7A. Bring down that negative 4, bring down that 2A squared, and you have 4 terms. So a couple things with decomposition. Number 1, you always decompose that middle term. Number 2, you will always end up with 4 terms. 100% of the time you'll end up with 4 terms. Then you split it in half and group factor. So what you could take out of a 2A squared and an 8A is a 2A. That goes in front of your bracket, solution in the bracket. So A plus 4. On this side, I could factor out a 1, and it's always the sign of the third term is the sign of what you're factoring out. So it's a negative 1, A plus 4. The nice thing about PSA 2 is there's a check involved, and the check is this guy here. These two brackets will always be the same if you factored correctly. So if these two brackets are different, you made a mistake in your factoring. But because they're the same, I'm going to factor out that A plus 4. And my second solution is whatever's remaining. So 2A minus 1, or I should say my second factor. Now I need to go and take out those A's and put in cos. So one of my factors is cos of x plus 4, and my other one was 2 cos of x minus 1. Okay, class example 2. You guys, this will be assigned for homework, so make sure that you do that to make sure that your understanding is good. It's going to be just on factoring. Class example 2 is solving a second degree trig equation using a graphical approach. And then class example 3 will be this exact same question, but I'm going to say solve it algebraically. So these next 2 questions are just making sure that you are good with the algebra and the graph. If we do this graphically, there's 2 different approaches I could do. I could bring everything to one side of the equal sign. So I could do 2 sine squared x plus sine of x minus 1 is equal to 0. And I could graph this. It would be a sine graph, and I would be looking for my zeros. That's one approach, and it would work. You could try it. You'll get the exact same answers. The approach that I'll do is I'll do the intersect approach, y1 and y2, and it's going to be a second calculate, I believe it's number 5, intersect. Okay, this is our given domain. Super important because it tells me 2 things. It tells me that they want it in radian mode, and it tells me what to set my window at. So essentially, they want me to go from 0 to 2 pi. And so for my x's on my window, I'm going to go from 0 to 2 pi. Now, the scale factor. You either choose pi over 6 as a scale factor or pi over 4. Sometimes they do pi over 2. I'm just going to use what the book did, and they actually did a scale factor of pi over 2. But again, pi over 2, pi over 6, pi over 4, those are the most common scale factors. For my y's, let's go from -3 to 3, scale factor of 1. Okay, so everybody take out your calculator, punch this in y1, punch that guy in y2. Let's look for the intersects. So I'm in radian mode. Here's how you would enter sine squared theta. So 2 sine x, close that bracket and square it. Here's my y2. For my window, go 0 to 2 pi, and then pi over 2 here as my scale factor. And for y's, change your window from -3 to 3, scale factor of 1. This is what your graph should look like. And your solution, remember, is always the intersect. So according to this, I've got a solution here, a solution here, and a solution here. So I'm going to show you how to find those solutions. Second function, calculate, number 5. We're looking for an intersect. I'm first going to go to this first value, hit enter 3 times. Now that's my solution, but it says give solutions as exact multiples of pi. So what is this in pi radians? How you figure that out is you go to your main screen here, and we're going to get them to give us that x value. So hit the x button and hit enter. Divide that number by pi, and then math one fraction. So that first solution is pi over 6. Okay. My second solution will be this intersect here. Second function, calculate a value. Sorry, an intersect, number 5. Scroll over to where you're close to the 2 intersects and hit enter 3 times. We need this in exact multiples of pi. So get out of this window and get your x value, divide it by pi, and then math one fraction. So that second solution is 5 pi over 6. Click pause for a minute and get that third solution. And that third solution, when you get it, is 3 pi over 2. So make sure that you guys are getting that. Okay, so what happens is pi over 6, how are we going to write this as a general solution? So on my unit circle, pi over 6 is at a reference angle of 30 degrees, so it'd be right here. That's pi over 6. And each time I do a revolution or I add or subtract 2 pi, it's going to go back to that exact same coterminal angle. So what it essentially wants when it says what's the general solution is what are these answers and then every other coterminal angle that exists. So how I would write this is I would say x is equal to, state this solution, pi over 6 plus 2 pi n. So n belongs to the element of integers. That means I could either, n could be like a positive number and I could go in this direction, or n could be a negative number and I would go the opposite direction. Then I'm going to say comma, 5 pi over 6 is a solution. So now I'm going to write that second solution plus 2 pi n. Right? So at 5 pi over 6, every time I add or subtract 2 pi, I would get a coterminal angle. My last solution was 3 pi over 2 plus 2 pi n. So 3 pi over 2 plus 2 pi n. And then now that I've sort of stated all three of my solutions, I'm going to say comma, n belongs to the set of integers. So it's like a huge general solution that's taking care of all three of my solutions in one. Flip to now class example number 3, which is this exact same question, but how would we solve this algebraically and get those exact same 3 solutions? Whoops, I forgot to clear this. So just give me a minute to clear this. Okay, let's do that exact same question algebraically. Bring everything to one side of the equal sign. So add sine x and subtract 1 to both sides. And what I would get is 0, 2 sine squared x plus sine x minus 1. You are factoring right here, right? So you need to recognize that this would be a PSA 2 question. So 2x squared plus x minus 1. And we're looking for what gives us a product of negative 2 and a sum of 1. And the answer is 2 and negative 1. So split this in half. Or sorry, say to yourself, how do you decompose 1x into the answer? 2x minus 1x would give you 1x. So 2x minus 1x. Bring down that negative 1. Bring down that 2x squared. There's our solution. Or sorry, there's our 4 terms. Split these 4 terms in half and group factor. So take out a 2x over here. And we would be left with x plus 1. Take out a negative 1 over here. And we'd be left with x plus 1. I know I did this correctly because my 2 brackets are the same. Therefore, my 2 factors are x plus 1 is one of my factors. 2x minus 1 is my remaining factor. because we're solving, where you always set it equal to 0, go through and put in an x, or sorry, a sign of x every time what I replaced it with. So my solution is 2, sorry for this guy here. Okay, x with sign of x. So sign of x plus 1, 2 times sign of x minus 1 is equal to 0. Set each factor equal to 0 and solve. So sine of x plus 1 is equal to 0, and 2 sine of x minus 1 is equal to 0. This solution is, they're asking, okay, well, where is sine of x equal to -1? The second one is, where is sine of x equal to 1? And then we got to divide by 2. So where is sine of x equal to 1/2? Unit circle, unit circle, unit circle. We cannot stress that enough. I will show you how you would find this if you don't have your unit circle, but you guys, it's just going to make it infinitely easier if you've memorized this. So remember that sign is y. Where is y 1/2? Before we even do that, according to the cast rule, sign is positive, because this is positive 1/2, in quadrants 1 and quadrants 2, quadrant 1 and 2. So I've got 2 solutions, okay? I'm going to go to my unit circle and I'm going to say, okay, well, where is y 1/2? Here and here. So my solution, x is pi over 6 and x is equal to 5 pi over 6. So x is equal to pi over 6 and 5 pi over 6. Those are my 2 solutions. How would you do this if you froze and you forgot your unit circle and you lost your mind? How would you guys do this? So what you would do is you would find what the angle is. So inverse sine of the absolute value of 1/2, which is just 1/2. That, remember, always gives you your reference angle. So second function sine of 1 divided by 2 gives me a reference angle of 0.5235. Divide that number by pi. Divide that number by pi. And math 1 fraction it. And my reference angle is 1 pi over 6, which is pi over 6. So this gives you here pi over 6, which is equal to xr, which is theta r, your reference angle. So what you would be doing if you didn't have your unit circle is you'd be saying, okay, one of my solutions is here, which is pi over 6, and so that solution would be pi over 6. My second solution is here, and if the reference angle is pi over 6, then the angle in standard position would be pi minus pi over 6, and that would give you 5 pi over 6. Okay, so pi over 6 and 5 pi over 6. And if I just go back to this class example 2, let's see if we had pi over 6 and 5 pi over 6. So we've got these two here, pi over 6 and 5 pi over 6. How do we get this guy here? That last one is going to be from sine of x is equal to -1. What you just have to sort of realize is that if you have -1 here or 0 here, you are on your axes. So put your 4 coordinates on. So here, 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 and here. These coordinates are 1 and 0, 0 and 1, -1 and 0, 0 and -1. Where is sine -1? Where is y -1? That would be right here, and this is at 3 pi over 2. Okay, so my last solution is x is equal to 3 pi over 2. And then remember that the general solution is stating all of these again. So for B, how you do that one, state your each solution, and every time you add 2 pi radians to it, you're going to get back to the what are all of the coterminal angles at pi over 6. right? At 3 pi over 2, if I add 2 pi radians, I get back over here, which is a coterminal angle. If I subtract 2 pi, I get back over here. Okay? Let's keep plugging along. Class example number 4. I'm going to skip A. Watch his video to get the full worked out solution. But just to show you, 4x squared minus 1. If you were to factor this, you should be seeing that this is a difference of squares. So you'd have 2x minus 1, 2x plus 1, 2 sine A minus 1, 2 sine A plus 1 is equal to 0. We're looking, where is sine of A 1 over 2, and where is sine of A negative 1 over 2. Okay, that's how you'd be doing this one. You'd be setting up a cast rule for each one. Here sine is positive in quadrants 1 and 2. So where, I might as well finish this, you guys. Where is sine 1/2? Where is our y equal to 1/2 on our unit circle? And y is 1/2. Where is my unit circle? Oh, it's up here. So y is 1/2 at pi over 6 and 5 pi over 6. And then the second one was, where is y negative 1/2? Where is sine equal to negative 1 over 2? And that would be negative 1/2 would be 11 pi over 6 down here. And this guy here, 7 pi over 6. Okay. So your solution for this would be A is equal to, we have pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. This question here, solve this algebraically. You have to factor this. What can you factor out is a tan of x. Tan of x. Tan of x goes in front of your bracket, and the solution goes in the bracket. So tan of x plus 1 is equal to 0. We need solutions where tan of x is equal to 0. And this guy, they want to know, well, where is tan of x equal to negative 1? Okay, let's do tan of x is equal to 0. So for that answer there, tan, remember, is y over x, right? So we're going to do the same thing like we did in the previous example. We're going to be somewhere on our Cartesian plane. 1 divided by 0, 0 and 1, negative 1 and 0, 0 and negative 1. 0 divided by 1 is 0. So this is a solution here. This guy here, 1 divided by 0, is undefined, right? Here's another solution. 0 divided by negative 1 is 0. And this guy, negative 1 divided by 0, this guy is also undefined. So within our given domain, so they want solutions less than or equal to 2 pi, greater than or equal to 0. So what that means is that right here, we start at 0, and that is a solution. Then pi is a solution. Then 2 pi is a solution. So we actually have within that domain 0, pi, and 2 pi are solutions. So x is equal to 0, pi, and 2 pi. Now, if I said, well, what would the general solution for this be? Every time you add pi, you're going to have a solution, right? Add or subtract pi. So what the general solution would be, how we would write that, general solution is just pi n, and n belongs to the set of integers. Because pi n, so where's pi, right? So go to pi. Pi's right here. If I subtract 1, I'm going to get here. If I add pi, I go back here. Add a pi again, I get here. And I keep adding pi's, and I will get my general solution when I add or subtract pi's. Now we have to figure out, okay, where is tan -1? So according to our cast rule, tan is negative in which quadrants? So in quadrant 2 and in quadrant 4. If you go to your unit circle, so students that are in my class will have written on their unit circle where tan is -1. But what's going to happen is the two quadrants where you divide y by x, this guy would give you a solution of -1 in quadrant 4, and this would be our solution in quadrant 2 according to cast. And if you needed to see y, remember that tan is y divided by x, so it would be -√2 over 2. Now instead of dividing by this, I'm going to multiply by the reciprocal. So times 2 over √2. And what happens? √2 over √2 cancels. 2 divided by 2 is 1, and we've got a negative. So 7 pi over 4 and 3 pi over 4, those are my two solutions. So x is equal to 3 pi over 4 and 7 pi over 4. So this question actually has 5 solutions. Now, if I was to write a general solution for these two, so I'm just going to show you what happens on my unit circle. So 3 pi over 4 and 7 pi over 4. So let me go here. Let's erase this. 3 pi over 4 and 7 pi over 4. Okay, one of my solutions is this guy, and here's my other solution, that guy there. This makes a straight line, and if you watch any of Mr. Trimble's videos, what he sort of says is you want to look for any time you see what's called like the blade of a propeller. So a propeller blade has a straight line. This is like a 180-degree line, right? And what would happen is if I said, okay, well, what's my solution? You take your smallest angle in standard position, which would be 3 pi over 4, and say to yourself, well, what do I have to add in order to get to this solution? And if this is a straight line, what you're adding to 3 pi over 4 is pi. And then from here, to get to all my coterminal angles, you keep just adding pi, adding or subtracting pi. So the general solution is your smallest angle in standard position, which is 3 pi over 4, plus pi n, and n belongs to the set of not real numbers and belongs to the set of integers. Okay, and that's how you would give your general solution for 3 pi over 4 and 7 pi over 4. Okay, last class example. This one, you guys, I will not do A. It's pretty straightforward. Make sure your calculator's in degree mode. This would be a PSA 1 or an inspection question by factoring, and you could watch Trimble's video that we will upload. For this guy here, I want to do this one, especially because of this domain. It's a really complicated domain when they write it like this. Those of you watching the podcast with my friend who podcasts this, she explains it really nicely and she does the same method that I do. What you want to do when you get a question like this is you want to split your domain into a positive and a negative domain. So my negative domain would essentially be from negative pi to 0. So it would be from theta is less than or equal to 0, greater than or equal to negative pi. That is one of my domains. So essentially what that means is from 0 to negative pi, I'm going to look for solutions in this region, and I'm not going to count up here. Then I break my domain into what's called the positive domain. So the positive domain here, I put a 0 here, and it would be theta is less than or equal to pi, greater than or equal to 0. And then this domain, if I'm going from 0 to pi, they want where you're less than pi, but you're greater than 0. They would want the solution in this region here, and we would not consider our answer there. Okay, so again, whenever you see something written like this, write it into your negative domain and your positive domain. This is a, okay, so they want us to determine the zeros. So they want this guy to be 0. This is going to be a PSA2 or a decomposition factoring. So 2x squared plus 5x minus 3 is equal to 0. We're looking for what gives us a product of -6 and a sum of 5. And that answer is 6 and -1. Split this, decompose 5x. How do you get 5x based on your answer? 6x's minus 1x. Bring down that minus 3. Bring down that 2x squared. Split it in half and group factor. 2x and 2x. -1, -1. 2x and x plus 3. -1 and x plus 3. Okay, one of my factors is x plus 3. My other factor is 2x minus 1. Because we're solving, you always set your factors equal to 0. Let's take x out, and they wanted x to be cos. So cos of x plus 3 and 2 cos of x minus 1 is equal to 0. From here, solve for cos for each one. Cos of x is equal to -3. Over here, cos of x is equal to, you should see that that's 1/2. You could try to punch this into your calculator and you'll get an error over here. I'll show you. So do they want this in degree mode or radian? So they want it in radian mode according to my domain. So second function cos of -3 is error. So we're going to write no solution for that. Basically, cosine sine could never be greater than plus or minus 1. So you would just find that on your calculator, right? And actually, did I do the absolute value? Let me just have a look at that. No. So second cos, the absolute value of -3 is 3, but we still get our error. So we would say over here that we have no solution. This side, unit circle. Who knows their unit circle? Where is cos 1/2? What we're looking for is, remember that cos is x? So I'm looking for on my unit circle, where is x 1/2? So going to my unit circle, x is 1/2 here. So pi over 3 is one of my solutions. And then according to CAST rule, so C-A-S-T, cos is going to be positive in quadrant 1 and in quadrant 4. I'm looking at, again, where's x 1/2? There's my second one, which is 5 pi over 3. So I have two solutions, pi over 3 and 5 pi over 3. Okay, except we've got to go back now to that domain restriction. So let's do this domain restriction. So within the positive domain, we're looking for where x is from 0 to pi. So within that domain, my solution would be right here, pi over 6. So that stays as a solution. X is equal to pi over 6. I'm happy with that. And I'll accept that. Now, within the negative domain, so negative domain is from 0 to -pi. We know that this guy's a solution here. Sorry, I drew this one wrong. When x is equal to 1/2, that's this guy here. Okay, so my first solution in the positive domain is x is going to be equal to pi over 3. Now I need to find my solution in the negative domain. So the negative domain is down here. And I know that 5 pi over 3, that would be my solution if I was able to go my angle in standard position. But for my negative domain, it goes this way. So that reference angle is negative pi over 3, right? So what you pi over 3 up here is a solution. And then this, we know that the reference angle is pi over 3, but that angle over here would be negative pi over 3. So my two solutions, why am I saying pi over 6? It is pi over 3 and negative pi over 3. And here's the remaining homework that you could try.